Hey everyone, Greg here. How are you this evening? It was just a beautiful day in Oregon today, and they said it was going to get really hot, but didn't quite get there. We only get about 1 or 2 weeks of really hot weather, and so that's just been a good summer. I'm very grateful for that. But so here's our week 4-5 transition video, and first I want to say I know that getting a handle on the hypotheses was challenging, but I think you've got it now. And one of the things you should start doing is, you can do this with Google. When I was in school, you couldn't. Just Google some of these educational quantitative dissertations and download the PDFs and read them, and you'll start to see that it all follows certain formats. And the way that I presented the hypotheses to you, they're usually presented the same way. There might be a minor variation in the words, but they're all a statement about equality or inequality of a quantity that can be tested statistically. So a hypothesis has to be testable. All right. So one of the things that I wanted to clear up on hypothesis before we get going is, of course, you can have two kinds of hypothesis. They can be non-directional, which would be, I drew a little picture here for you. I don't know where it is. Non-directional, one mean is equal to another mean. And then the alternative hypothesis of that null hypothesis is that one mean is not equal to the other. A directional hypothesis concerning a mean is that the 8th grade test scores in Kansas are greater than or equal to the 8th grade test scores in Oregon, and the alternative hypothesis is that the 8th grade test scores are less than the other 8th grade test scores. So every null hypothesis has to be accompanied by its alternative. Okay? And the pair can either be directional or not. Now, here's one thing that's commonly confused. When you have a correlation, so got a little chart here. So let's say that finger length sort of correlates with income. As the finger length gets longer, income goes up. Now, that's what's called a positive correlation, if it exists. Now, if it was the x's, the correlation probably wouldn't exist. Okay? And if you look at the bottom, as finger length goes up, income goes down. So that's what's called a negative correlation. However, there's no such thing as a directional correlation. Now, there is a directional correlation, but we sure won't use it in this course, and it is really hard to determine statistically. So there's only directional correlations. There's not a non-directional correlation, okay? And either positive or negative. So we'll get into that, I think, in week 7. All right, now, this week, the whole week is devoted to statistics, and so week 5, 6, and 7 are all calculating statistics going toward your final project. And what you'll do this week is you have to have SBS working, and there's 3 assignments. One is to put in a set of numbers and simply calculate the mean, median, and mode, just to make sure you know how SPSS works. That goes pretty well. And then the second assignment is to calculate the standard deviation of a normal distribution. And one of the things that you want to start to think about now that you're becoming quantitative researchers is there's the word bell curve is that's kind of street language. There are variables that are distributed normally, meaning the mean, median, and mode are the same thing. And so let's refer to it as a normal distribution. A non-normal distribution could be skewed to the right or skewed to the left. So all these concepts, yes, they're in the book and they're not presented all that well some ways. You can look in statistics books or online, and all these ideas are universal. So they're not particular. You can bounce your ideas off of other sources. So I think the first 2 assignments are going to go pretty smoothly. And if you're having any trouble at all with SPSS, I'll give you some help. And I'm going to send out some screen captures of how do you put the data into SPSS. So the only real challenging assignment comes at the end of the week, and that has to do with what is called the central limit theorem and statistical significance. Now, the central limit theorem is at the heart of what's called inferential statistics. It's why we can make a guess about a population from a sample. And then statistical significance is also discussed in the assignment. But please wait on those two. I'm going to put out some very specific information on what the central limit theorem actually means and how we use it. And then I'm going to put out some real clear definitions on what statistically significant means. And I'll just give you a quick example of that. So let's say your son comes home and goes, "Hey Mom, I got up to bat 8 times and I got on base twice." And you go, "Oh, that's good." And then the next day he comes home and says, "Hey Mom, well, I got up to bat 8 times and I got on base 5 times this time." And you go, "Oh, Bobby, that's a significant increase." Well, that's using the word significant in everyday language, but that's not what it means in statistics. In statistics, it has an actual meaning. And so let's say we take a sample of 8th grade test scores from Kansas and a sample of 8th grade test scores from Nevada, and we find that the sample means are different. Now, we know the sample means are different, but we don't know that they're statistically different unless we're pretty sure that the means of the populations from which they came from were different. So 2 sample means can be different just due to sampling error, because you could have just got 2 random samples and the means are different. But unless from the properties of the samples you're pretty confident that the population means are different, then you don't have a statistically significant difference. And so the word statistically significant, that's going to become part of your life if you're a quantitative researcher. So no result from a statistical test means anything unless it's statistically significant. But we'll put out some information on that. So I just want to say, I know getting a hold of the hypotheses was a little challenging. The other thing is, some people wrote some research designs that were qualitative or case study, but that's not the research designs that we're working with here. This is the quantitative methods course. And the only research designs we basically have are comparative, so you're comparing 2 groups for a mean, or you're comparing 2 groups for a proportion, or you're taking an assumed mean of a population and comparing it to a mean that you believe exists. Or there's correlation designs. And so there's some variations on those, but you want to start thinking my design has to be quantitative in nature for the final project. And some people, when they go into their dissertation, they'll choose to do case studies and qualitative research, but at this point in time, just keep thinking quantities till we're done. And I really believe everybody's going to be successful here. So thank you for, we had some good conversations this week. Thanks for the communication. Feel free to ask at any time for any questions. I enjoyed doing this. I'm pretty busy, but I love to talk to you. And I think that's about it. We're going to have a good week, and it's going to get very specific and to the point. So just pay attention to the announcements and follow that information, and everybody should do real well. Okay, we'll have just a wonderful week, and thank you very much. Okay, goodbye.